All right, guys, so this is one like 3b. What do you got, Jeff? 5w cubed minus 40 a cubed. Some of you guys try to immediately break this up little to big dude, but that makes no sense. Is this a difference of cubes currently? Now look at the third power. That is a good thing. That part is good. What about 5?
GCF.
Can you cut 5 up? Yeah, so what do you always try first? Always. GCF. Yeah. Now some of you guys did this, so if I take a 5 out, what's left?
8.
Now some of you guys did that and stopped. Now, you know. That's like me saying factor AT completely and you say 2 times 9. Okay, so that piece can go further. Now it's little dude, big dude. Now you uncovered the cubes. You got the 5 out of the way. Does that make sense? So nobody had that problem, but everybody had that problem. Somebody, yeah, the more that statement makes sense, the more you understand math. Everybody had this, but nobody had this. Okay. You're all like, what meds does this guy need? Yes? Sure. So now we've uncovered a cubes. What do I do with w cubed?
Break it down.
2 times 2 times 2.
Yeah, this will be 2a times 2a times 2a. Oh, by the way, before I forget, what do you guys think about this? I asked you if Steve was bothering us with the lecture, but I personally, we're going to change rooms because I know that must have bothered somebody and you guys are just being nice. Remember when you could hear the lecture? Also, when he gives a test, I'm going to do the same thing in his class. You know what I mean? So I'm just going to, I found a different room. I got to kind of put all the forms in, so we're just going to have a different room. So if you really like this room with our door that doesn't quite work, I'm sorry, we're gonna leave it behind. I got a room upstairs and a room downstairs. I got to check which one actually is free for the whole semester. Are you guys with me? So we're gonna move, and I'll let you know all about it. We'll probably start here, and I'll take us down there. Are you with me? Okay. Just while I was thinking, because I just heard him. This guy just comes for the ride. He's done. He's just out there. Little dude, big dude, right? What goes in the little dude? Just the little tiny dude. 1w minus 1,2a. What goes here?
W squared.
The other 2 w's. What goes here?
2a squared.
4a squared.
4a squared. Always positive, right? What's the sign of the middle term going to be?
Always
Opposite, right? And then what's the middle term? 2 all. Yes.
Why did you do negative 2a for the first one?
Here?
Yeah.
Because it's minus.
Oh, okay.
Yep. So if that would have been a plus, that would have been a plus, and that would have been a minus. That would have been the only difference. I wish I knew. Because. Do you all agree to get w cubed? Check, right? Check. Do you all agree to get minus 8a cubed? Check. Don't I also get minus 2a w squared? Right? Yes? If I FOIL this shit, don't I get minus 2a w squared?
Yes.
Is that part of the answer? So far I'm like, oh. What's up?
How did you get 2AW?
Yeah, that's what I'm wondering. I still didn't follow.
I am getting there. So this is what I'm doing in response to your question. So I'm answering your question. So, you with me so far? Don't I get something I don't want, apparently? So I'm hoping it's going to cancel, right? Because you guys agree, I need you to agree with me. W cubed, part of the thing. 8a squared, a cubed, negative is part of the thing. That's not part of the thing. I hope it's going to cancel, right? Why are we so happy that I get a w cubed right there? Why? Because it's in there, right? If in this, right at this step, why am I kind of concerned that I got this?
It's not there.
Because it's not there. Yes?
Yeah.
You guys all with me? All right, okay. Well, we're not done, are we? We're not done foiling shit, are we? So I'm hoping it's going to cancel. I also get a w times 4a squared. I get a 4a squared w, don't I? Now, if I look at what this does, watch what that guy does. What's negative 2a times 2aw?
4a
Negative 2a.
squared W?
Minus 4a squared w, die.
Huh?
What is w times 2aw? 2aw squared, die. I need you to understand. Before I think about him, pretend like he's not there, I get extra shit. It can't be the right answer, but the minute I put him there, he cancels the extra shit. What's this guy's job? Clean up. Without him there, I am wrong, because I get extra terms that's not there, correct? There's no way that this equals this, because I get extra shit. Put him there, bam. What always works? What always works? This times this. So why is it 2aw? One answer is because it cleans it up, but why is it 2aw, Jeff? Because 2a times w. That's what goes in the middle always. Not 2aw, but whatever the hell that is times whatever the hell that is, right? One of each, two of each, product in the middle. One of each, you can even make it a song. One of each, two of each, whatever the hell you gotta do, right? You don't have to dance. Or whatever it was I was just doing.
Let me take out.
Yes,
Maybe 3C or something like that.
sure. Oh yeah, okay. Oh, let's see if I can make something that's different. Sure, let me see. I'm making one. I'm doing it live. Let's see. Wait. All right, Jeff. Clear your thoughts. There you go. You got it now. Okay. What tells me this is going to be a little bit harder than another kind of three-term deal? What is there that I wish wasn't there? There's no, oh, yeah, that makes sense. I was still stuck on cubes. All right, thank you. That I can change, because it's my problem, okay.
It's that 8.
The 8, so there's not a 1 out front. So I can't just immediately go to that, right? So how do I take the 8 into account?
Multiply that.
Yeah, 8 times 10. So I don't find factors of 10 to add to be 21, thankfully, because there aren't any. I find factors of 80 that add to be 21. And if the magical X helps you, I'm cool with that. I don't know why. It doesn't change the work. You're doing the exact same work. But if you like the little magic X, I'm not going to stop you. If you don't know what the magic X is, it doesn't matter. You guys see what I'm saying? Now you need factors of 80 that add to be 21. Let's do it the reverse way. Can you give me two numbers that add to be 21? Everything's positive, right? Yes? Everything's positive?
Yeah.
So give me two numbers that add to be 21.
20 and 1.
21! Does that multiply be 80?
Nope.
No!
40 and 2?
No. So let's, instead of finding factors of 80, let's
Well,
find
what
things that
adds to 21.
add to 21. Again, I need two numbers that do two things, correct? It does not matter which thing they do first. They just have to do both. So instead of making a list of factors of 80, I could just make a list of things that add to be 21.
15 and 6?
15 and 6. Now what's funny is, what's 15 times 6? Yeah. 90. That's getting close, isn't it? That's close. So maybe instead of 15 and 6, maybe it's,
14 and 7?
let's see, that ends in an 8. You see what I mean? 14 times 7 would end in 8, correct?
Oh, yeah.
You see how I know when it's going to be wrong. It's got to end in 0. So what about 16 and 5? What's 16 times
Oh.
5?
Yeah, that
Yeah.
works.
Now, if you don't like that, you don't have to do it that way. You can take 80. You can start making factors of 80. 10 plus 8 is not 21, blah, 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 right? 16 and 5 is not like an immediate thing we think of for 80, though. Yes?
Yeah.
All right, so now that I know it's these, what do I do?
Okay, so it's gonna be eight b squared plus 16b minus 5b.
No, no.
Oh, plus 5b.
To make 21, right?
That's right, plus 5b plus 10. That's right.
And then you group. Is that cool? Or I mean, understood? I won't make you agree that it's cool. But is that understood? Or is that, you alright? So real quick, I wanna show you, watch. If it was this instead, if it was this, what do you got, Jeff? Sure. If it was this, I would find numbers that do what?
Multiply to be 28.
Multiply to 28,
And add to be 11.
add to be 11. What's in front?
1,
What's 1 times 28?
28.
So that's why I don't even think about it. I just take factors of 28 that add to be 11. Here, I don't take factors. I take factors of 80 that add to be 21. It's still the same process. I just have to take that number into account.
It's not gonna be 14 and 2.
Where do you mean? I'm sorry.
Oh, I'm still looking at your problem.
Oh,
I
now
said
you
it's not going to be 14 and 2.
Yeah, no. Oh, this one?
Yeah.
Oh. No, it won't be 14 and 2. What multiplies to be 28 and adds to be 11?
7 times 4.
7 times 4, yeah.
Works for me.
So that's easy, yes? Because the first number's a 1, this has to be BB. That's a frickin' 8. It could be 4, 2, 8, 1, 1, 8, 2, 4. I mean, my God, I don't know shit. That's why it's a little bit harder to do when the first number's not a 1. Now, real quick, I kind of skipped this, but it's because I could see this doesn't work. But the very first thing you always try is,
Greatest common factor.
and is there a GCF? No. If I could take the 8 out, that would kick ass, because then it would become
Technically,
that.
there- oh wait, no, that's 21, not 2, never mind.
Make sure, didn't we come in and not get their test back yet? We got the test, oh. Martin? Yeah. There's test grade, current average, what it would become if you make corrections, you can make corrections on this. Yeah. Oh,
8b plus 5.
many versions of the test, so let's see. What was your 4C?
G over F.
Okay, good. Everybody have what they want from up here?
Yeah.
Okay.
8b times 5 plus 8b plus 5 times 5b plus 2.
8B, B plus 2, yeah, 8B plus 5, B plus 2.
B plus 2, yeah, that's what it is. I can't say it, but I know what it is.
As long as you can write it, you're good.
You put on the extra credit, you put a cross.
Yep, yeah. If it was right, I'd put plus 2.
So we can correct those as well.
No,
No?
you get one shot at those. All right, so let's say I want to know what G over F of, watch F, 4. Does this say, does anywhere in here say G of X? Nope. A lot of you guys were just putting that whole thing over this thing with the 4 next. No. What's the inputs? What is the input for both functions up here? 4. 4 is the input. So another way to write this is G of 4 divided by F of 4. So then it becomes 2 little mini problems. So you can even put it on the side if you want to. How do you do G of 4?
4 times 2
Yeah. So it'd be 2 times 4 plus 1 inside of a square root. 8 plus 1 is 9. What's the square root of 9? 3. So there's a 3 there. So the problem needs me to know g of 4. I don't know it. I figure it out and then I put that in. What else does a problem need me to know? F of 4. So what's f of 4? Yeah, 4 squared minus 3. 16 minus 3 is 13. Done. Yeah.
I was gonna say for the next problem.
Is everybody cool with that? Now, everybody had a problem like that on number 4, but some of yours was a different letter. You guys with me? Yeah, okay. Yeah.
Do, 4A, I mean, or something similar.
Oh,
That's what I messed up. Cause I'm able to see the domains when it's graphed, you know?
sure, of course.
The range of the graph.
Yeah,
Without it, I would.
yeah, because the graph means all the work's done for you. So if I give you, let's say, square root of 2 minus 5x, and g is, I could have used those, I don't know. No, I need a problem like this. X minus 1 over 4x plus 2, sure, whatever. I want to know the domains for each, right? Let's start with g. In that type of function, what can't happen?
Can't be, the bottom can't be, 0, or can't be.
So for this guy's domain, you just said the bottom can't be 0. All right, what's the bottom?
4x plus 2.
4 plus 2.
It was 1/2 or negative 1/2.
Great, I want to see the word. Can't be. Can't be. How do I write that? Yeah, not equal to 0. And then solve that.
Solve it like. move
Solve it, yeah, get x by
move
itself.
Over, and then find the, negative 1/2.
Yep.
That would be the domain.
No.
No, negative 1/2 and then in a bracket and then 0, u, 0, and then, right?
If you want to,
Interval notation.
I would just write it like this. X can't be negative 1/2. Right?
X can't be negative. Oh, okay.
Yep.
That's it?
What about the f function? What must happen for the f to work? Can you say it in English? What's going to happen for the stuff? Square
Can't be
root.
negative.
What can't be negative? What can't be negative? Inside. Okay, so the inside must be what? If it can't be negative, it must be
4, 0.
at least
0.
0.
Wait,
So now,
but if it doesn't have a denominator, then, like, my g of x doesn't have a denominator, that would be my f of x.
do you have a square root function?
Yes,
Do you have a fraction function?
yeah.
Okay.
I'm talking about-
Yep.
Switch it.
So this guy has a problem because it's a fractional number and the bottom can't be 0. This guy has a problem because I want to keep things real and it's got a square root and that could come out complex, right? To keep this defined, the bottom can't be 0, blah, blah, blah. To keep this real, the inside must be at least 0, correct? So that's what I just say in English. You guys all know this shit. What number do I put into a square root to keep it real? At least 0. So the inside must be at least 0. Can you translate what I just said into mathish? What's the inside?
2 minus 5.
2 minus 5x must be at least?
Greater than or equal to 0.
Yeah, now solve that fraction, you're done. Yeah.
Oh.
Yeah, it's awesome. So this is the thing. If I ask you, if I give you a function, say what's the domain, just say in English what the trouble is. Right, what if I give you this function, h of x equals x squared minus 2x? Does that function have any issues? Does it have a bottom with variables? Does it have some root? Is there any number I can't square and then subtract?
No.
I could do that with every number, correct? So what would the domain of h be? all real
Minus
numbers.
infinity to.
Yeah, negative to infinity, or just all real numbers, right? There's no issue. So what kind of functions could have issues? Root functions, rational functions, yes?
Wait,
Yeah.
when we move over, for example, minus 2x minus 8 is greater than or equal to 0.
No,
Yeah, I can't tell you mine.
no.
Alright.
You can ask me
Okay,
specific
okay,
questions.
okay,
You can
so-
ask me specific questions after class, but we're not going to do everybody's corrections for them.
No, I just have one question. When you move it over, you don't switch the sign to the other direction. Is that another rule for some reason? I don't-
When do I switch the inequality? When do I switch the inequality symbol? Like in this problem, if I do this, am I gonna get to a point where I have to switch the inequality symbol? Because what am I gonna do?
Divided by.
Yeah, so if you multiply or divide by a negative, you change what side of zero you're on, so the one that was bigger is now smaller. Does that make sense? When I multiply or divide by a negative, I change what side of zero I'm on, the order changes. So we did an example like this before. Which one's bigger? 2 or 1? Sorry, 2 or negative 1? 2 is bigger, crazy. Now if I divide by negative 1, I get negative 2 and 1. Which one's bigger now? 1. Sign flipped, right? Of course the sign flipped, because they changed what side of zero they're on, right? We did that before, no? Are you guys all right? Yeah, that's it, that's all, that's why it does. So when I multiply or divide by a negative, not just, is there a negative somewhere? No, if I multiply or divide by negative. So if I have this problem, how do I solve it? What did you just divide by? 2. Positive 2, so is that gonna flip? Nope. I know there's a negative, but did I divide or multiply by negative? Nope. Okay. All right, okay, that's enough. So if you have any other questions, you got tutoring, you got me, office hours, all kinds of crazy stuff. When are those corrections due?
Next test.
Next test. All right. All right, so let's talk about absolute value stuff. This is section 3.6, is that right? Yeah. So we talked about absolute value a little bit, but we really didn't talk about functions involving absolute value. Help me out, everybody. Let's start with the most basic function I could possibly have involving absolute value. There it is. Can you guys tell me how to solve this just by looking at it? What does this say? I need a number so that if I take the absolute value, I get 1. Okay, thank you. Can anybody give me a number that if I take the absolute value, I get 1?
Negative.
Good, so I either get -1. What other number?
1.
Yeah, 1. Maybe I do both. So inherently, absolute value equations have the possibility of 2 answers. So what I'm really asking myself is, what could I put in place of x so that when I take an absolute value, I get 1? Well, there's 2 possibilities. You guys all with me? Okay. Also, you can think of this visually. Absolute value means distance. So currently, there's not minus anything. So this is talking about how far away from 0 I am. So how many numbers are 1 away from 0? This one, that one. That's why I got those 2 answers. Right? Okay. So let me show you kind of like an example of what I really mean here. What if I had this equation instead? Let's see. X minus 3 equals 2. Okay, let's think of this visually, which you cannot always do. The minute the equation's a little bit worse than this, you can't really think of it directly, visually. But this says the distance between a number and 3 This is the distance between a number and 3, right? And I want it to be 2. So think of it visually. Here's 3. What numbers are 2 away from 3? That's really all that says. Yeah, 5,
2. No, 1.
1, right? You guys with me? Absolute value is distance. If the equation is really simple, there is a visual way to solve it. Will our equations always be simple? No. So thank God we're going to develop an algebraic way to solve it too, right? So let's see if the algebraic way matches up. 5 and 1 are both 2 away from 3, correct? Okay. So what number is inside the absolute value in this equation? No. Mm-mm. What number is inside the absolute value?
5 minus 10.
What is a variable? What is a variable? Number we don't know yet. Okay, so what number is inside of the absolute value? X minus 3. If x is 7, what number is this? If x is 7, what number is this? 4. X minus 3 is a number. So what is inside the absolute value? X minus 3, correct? What could I replace this with so the absolute value is 2? What could this equal so that the absolute value would be 2?
-2.
Yeah, good. If x minus 3 was -2, wouldn't the absolute value of it be 2?
That would be 1. Or no.
No, don't. If x minus 3 was -2, wouldn't the absolute value be 2? All right, let me do this. What can you put inside of here to make this true? 7 or -7, right?
Yeah.
So whatever is currently in here, do you agree that in order for this to be true, it would have to be 7 or it would have to be -7?
Yes.
Because that's exactly what you just told me. So coming back to this problem, what is in the absolute value of x minus 3? What's one thing that would make this work if that is -2? Or what if that is...
5.
No, you're not solving it. What number can I put in the absolute value to make it 2?
2.
I could either put -2 in there or I could put 2 in there.
Yeah.
Right? Stop.
I'm
I'm
looking
not
at.
asking you what is x.
Right.
I'm asking you, what would I put in here to make this true? -2 or 2, correct?
Yes.
So whatever is in here, what would it need to equal? -2 or 2?
Yeah.
Yes.
So this stuff was on the practice test, but it wasn't on.
Totally. Kick ass.
No, so stuff on the practice test.
No, again, we didn't make it as far as I thought we would. Right, so I had to cut some stuff off of the first test. It will be on the next test, yeah. So again, okay.
Yeah,
Makes sense.
so it doesn't matter like what is inside, as long as we have an equal to a number, we just have to find out what number will equal that number.
So guys, again, let's do this again. What would I put in here to make this true? Yeah, 5 or -5, correct? So whatever is in there has to be 5 or -5 for this to be true. Does that make sense? So if there is an x minus 1, x minus 1 has to be 5 or x minus 1 has to be -5. If either one of those are true, then the statement is true. Is that cool? That's all we're saying right now. So if I don't put anything there, you guys know it's 5 or -5. So whatever the shit is in here must be 5 or -5 for it to be true. So when you have absolute values, you will always have 2 possible answers.
Yes.
Where the stuff is negative because the absolute value kills the negative, or where the stuff is already positive and the absolute value is like, oh cool, you're there.
So the answer would be.
Wait, all right, so going back here. Now I've got 2 simple equations. So yeah, what do you get?
1,
Add 3, you get 1.
5.
Add 3, you get 5. Does it match up with the visual solution we made? What's 2 away from 3? 5 or 1? Okay, 11. So almost always, there's this concrete kind of visualization of what we're doing.
Yeah.
Yeah. So that is the concept, right? Whatever's inside the absolute value could equal this or negative this. Okay. Now, the nuts and bolts of how to solve an absolute value equation, we've got it now. So if I make a worse equation, if I've got absolute value of 5 minus 3x equals 11. So you got, I showed you the concept. So now this is like a nuts and bolts practical approach. How do I solve this? Well, the inside number can either be 11
Or minus 11.
or the inside number can be negative 11. Because how many numbers have an absolute value equal to 11? 2 of them. Let me stop for a minute. And then you just solve those two. So 5 minus 3x is a little placeholder. What could I replace that with? What number could I replace this with to make this true? 11, there. So if I replace that with 11, it's true. Or if I replace this with negative 11, it's true. So absolute value stuff, equations and inequalities, will always have the potential for 2 answers. And now you just got 2 little simple equations to solve, right? Go ahead and take a minute. Solve that, go for it. By the way, do you all agree with me that the inside function is worse than what we've seen so far? So a visual, there does exist a visual, it just would be a lot more complicated because there's more shit happening. So the visual solution idea does not work well once the function gets a little worse. So we just give up on it and we just do algebraic. All right, what do you guys get here? Negative 2, and then here. 16 thirds. Get gas. Yes. And of course, you can still plug the shit in there, right? So I plug a negative 2 in, I get 5 minus 3 times negative 2. I get 5 plus 6 is 11. Absolute value is 11, right? So you can still plug it in and check the solution, of course. Let me stop for a moment. All right, you guys do this problem here.
So, clarify, it could equal, that one could equal either negative 2 or 2.
So you,
That one should equal 3x, and 7 should equal either negative 2 or 2, right?
yeah,
Yeah.
okay. Keep it to yourself though for the moment.
Alright.
Well, it's too late for that. In general. Let other people have a chance to try it. So I always want you to understand the idea behind something, but at the very least you can get the just nuts and bolts, what is the approach? I would never teach it like this, but now I can just say, how do you solve that equation? Take the inside, set it equal to this, take the inside, set it equal to negative this. Solve. But at least I've shown you why that makes sense, right? So equal, either this is 2 or this is negative 2. Okay. And then you just solve. So here you get x is negative 5 over 3, or negative 3, 11. solve it. How do you solve this?
It would be -7, right?
Minus 7. So you get 3x is negative 5. And then
We do it after
divide by
the fact.
3.
I'll
Yeah.
let-
Okay.
And that's negative, or -5/3 is a acceptable answer?
Of course, yeah.
Okay.
So let's try it. Let's check x equal to negative 5/3. So if I put it in there, I get 3 times negative 5/3 plus 7. What happens here?
Cancels out,
Yeah, so I get negative 5 plus 7 is
2.
2. The absolute value of 2 is 2. Check. So it should be kind of obvious. Negative answers are completely fine because I'm going to be taking an absolute value. Now, I will tell you right now, I'm about to write a bogus equation down. This equation does not have a solution. I just want you to tell me why.
You want us to work it out?
Well, if it doesn't have a solution, no. But,
Because
absolute value is always, this equation requires me to assume that the absolute value equals, so I already know that there's no solution. Could I do the work and think there are answers?
Yes.
Hell yeah, I could just say 4 minus 11x equals negative 4, or 4 minus 11x equals 4. I get 2 answers and neither one of them work. So why don't I need to do any work? At the beginning I could tell that's bogus. There's no way in hell that, I don't care what you make x. No, absolute value is defined to be positive. Are you?
we put both in the negative, right? Or
Well,
no?
no.
I don't care what you put in for x. The absolute value can never equal negative 4.
Can they never?
So the whole purpose of solving an equation is what value can I put in for x to make this true? Ain't no x gonna save this thing. There's no way the absolute value of any damn thing equals a negative number. You guys see that? So then don't even do shit, right? Don't even, just immediately put, here's work, bam, no solution. You guys got it? All right, let's ramp it up. This one has a solution. I'm gonna write an equation that has a solution. It's about time, Jeff. All right, so. Go over there. Let's see. There's a major difference. There's a big difference here between what I've written right there and every other problem I've done so far.
Because if you add 7, it
Yes.
becomes positive?
So in general, we isolate the term that has x in it. We do that all the damn time. So don't just go, no solution, no, add 7. Then I see what the absolute value is trying to equal. Is that a bogus equation? No.
Because it's positive.
Yeah, because an absolute value could equal 3. All right, go ahead and solve it.
Is the value inside the thing, is that multiplying to -7 or subtract? Oh, it never is, so you used it.
Yeah, it's this business minus 7, so then get that 7 out the way. Is that what you're asking?
Yeah.
Okay. So what are my 2 cases? Either 3x plus 1 equals 3,
Or negative 3.
or 3x plus 1 equals negative 3. Why does that make sense? Because the absolute value of 2 things could equal the same thing, right? The absolute value negative something and absolute value is positive that thing, they both equal the same thing. That's why there's 2 possibilities. So what do you get for this? Subtract 1, divide by 3. 2 thirds. This guy, subtract 1 divided by 3.
Negative 4 over 3?
Kick ass. Alright, I like it. How you guys doing? I mean, so the nuts and bolts of this should feel pretty nice. I mean, that's really nice. You just immediately break it up into 2 little dinky equations. No problem. So here's like the ultimate, here's the ultimate level. So let's see. All right, now watch. This is not 11 equals 11, right? It's absolute value. So what can you put inside? Can anybody give me any 2 numbers I can put inside to make this true? It could be the same number, right? So I'll get us started. If there's a 1 and a 1, that's a true statement, correct? So we got one case. We've got one case. What if this equals this already? If those 2 numbers inside are equal already, isn't that just true? I really want this to make sense. Give me a number. Negative, positive, I don't care. 4. Is that a true statement?
Yes.
All right, give me a negative number.
Negative 6.
-6, is that a true statement? All right, now watch this. You ready? Now, so one case is the stupid numbers are already equal. So of course their absolute values are equal. You guys understand? So it's really the same as this first case. Either this equals this. Now, could I make one change to one of these and it's still true?
Yes.
What would you do?
Take away the sign.
Right? Is that a true statement? So if this number is equal to the opposite of this number, that's that case. Right? So either they're already frickin' equal, and of course the absolute values would be equal, or one is the opposite of the other one. You still get 2 cases, yeah.
You can do it to either side.
Yeah, totally, because I could just divide by the negative and it would be over there. So there's still only 2 cases.
So you multiply 6 negative by -1 basically. And
Yeah, you distribute that
and then
side.
also, yeah.
Yeah. So when you go to solve this, subtract 6, add 2m. I get m is negative 2/3. Or, what do I do here? Distribute that. Right.
You went very fast.
Hey, can you go over it again slower this time?
Yeah.
So we know where numbers are coming from?
Solve this.
Okay,
Don't say anything.
okay.
I really need this to be understood. If you do have issues with solving this kind of an equation, just come see me. In class, I'm gonna assume we can all do this. We have got to be able to solve simple linear equations, right? How do I solve any equation where the variables are all just to the first power? I just get all my m's on one side in this case and all my numbers on the other side, right? You see what I'm saying? Now, at the same time, I want to be careful because when we learn something new, your brain thinks everything's going to be new. Do you see how this new thing is one step that's new and then everything else is freaking old as shit, right? So this is just an equation I've got to solve, nothing special about it. It came from somewhere freaky, but it's just sitting there like, solve me, okay? So what do I do first here? So you can,
Add 2M?
yeah, I can add, sure, I can add 2m. I'll do one thing, I did two things at a time last time, but. So I get 4 equals 6 plus 3m. Right? So that's all this is, right? So very often what we're gonna do is we're gonna learn something new, and maybe the first or second step of a problem is that new thing, and then old shit takes over, right? So don't assume, since we go into a new section, everything's new. No, not everything can be new. Everything we've learned is still valid. It could still show up. We're just learning some new stuff, where to start. So what do I do now?
Take away 6.
Try to get all my numbers together, and then I almost always divide last, yeah. Okay. And then this other one, I do the same idea, except here I've got to distribute the negative, right?
And that negative came from, because absolute value is both positive and a negative value.
Yeah, the funny thing is, this equation has two absolute value symbols, correct? Do you notice though that the cases are the same? What's the first case here? This equals this, all right? So this equals this is the first case. What's the second case? This equals the opposite of this. Second case, this equals the opposite of that. That kicks a lot of ass. There's not a new thing to memorize when it looks like this. Two cases are the same. Either they're equal to each other, or one equals the opposite of the other one. Because the absolute value will kill that negative and make it equal again still. Right? So how do I proceed here?
Subtract 2M?
Yeah, add 2m.
Oh, that's what I meant.
So we get 4 equals negative 6 plus m. Add 6. So we get 10 equals m. So I get my two answers. So absolute value equations always have the same two cases that you do, and then each case is its own little problem to solve. Okay. So let me show an example that has only one answer. Right, so far every problem we've done has had two answers, correct? Or there was a problem that had no answer because it was bogus to begin with. So here's a problem that has only one answer. Actually, I gotta be careful. Let me do this. That's a lot. Let's just do this. Make that one little change. Make it x minus 2 over there. So can you write down the two cases and then I'll catch up to you? Okay, go for it. Write the two cases and then I'll catch up to you. So the two cases are always really nice. No work to write in the two cases. The first case would be what?
Minus x is equal to x minus 2.
Yeah, either the numbers are already equal, in which case, of course, absolute values are equal, right? Or
1 minus x equals negative x minus 2.
Plus 2, right?
well, it will be.
Oh.
Yeah. What's up? Go ahead.
Oh, I see.
Because, like, how do you?
Real quick, Are you thinking ahead, or are you okay with what I've written so far? Are you okay with what I've written so far? Okay, I agree with you. It's gonna lead somewhere weird, correct? Beautiful. This is why it's gonna have one answer. So let's solve this one. How do I solve this? Add 2, I like it.
Subtract or add an x both sides.
Add x. So then you get x is 3 over 2. Shoo, is that all right?
Yeah, I just got it confused.
I don't blame you, because this is gonna get freaky. So this one would be 1 minus x equals,
Negative x plus 2.
how do I get my x's together?
Add an x each other.
Add an x. And they both, now what I really find funny all the time is students just hate variables, but students will always try to save the x. X, and I'm like, let it die, it's dead. It's dead everywhere. 1 equals 2, what does that mean? Don't circle that shit. Right? Don't say, look what I've proven, Jeff. No. What does that mean? This equation has, because this equation is true when this is true. Bam. This equation is true when that is true. So is this equation ever true? No, no solution. So there's an example of a problem that's only got one solution.
1 equals 2.
Yeah, yeah. I do sometimes get students that are like, what did I just do? Yes?
If there's only one solution, then there's like no solution to the whole problem.
No. This is an answer, and then I'm gonna go see, are there more answers? Did I get any more answers? Did I get any more answers?
No.
Nope, so this is the only answer.
Okay.
This
So we're not
part
necessarily
doesn't give us additional answers, I only got the one.
So we're not necessarily proving the original. Absolute.
No, of course you are, yeah. My one solution I got, I can plug it in and see if it works, and it will. You guys with me? Not sure, is that all right?
Yeah.
Okay,
On the no solution one, would it be wrong to cancel out the 2 or the 1?
no, yeah, if you wanted to keep going, what would you do?
You just, minus 2?
Oh, you want a minus 2? Sure.
Minus
And what do you get? 1 minus 2 is
1.
negative 1? 2 minus 2 is,
0.
is that true?
No.
Nope.
Would be no solution.
So no matter what you do, it's gonna be not true.
Okay.
Yeah. Alright. So not too bad, right? I mean, the nice thing with absolute value equations is it's always the same thing. Either the two are equal to each other, or the one is equal to the negative of the other one, right? You just gotta be careful for the ones that are undoable. So here, let me ask you this. Would this have a solution? Or maybe at least one solution, let's see. So is the absolute value by itself?
-1, so you divide both sides by -1,
X would be 0.
right?
Can I subtract 2 first?
Yes.
So then I get negative x plus 3 equals negative 7. Now come at me, Philip. What do I do
Now
now?
that you divide both sides.
Now I divide by negative 1. X plus 3 equals 7, right? What kind of number is the absolute value of x plus 3? What kind of number is it? What's the only thing I know about it? It's the absolute value. It's not negative, correct? It's maybe positive, are you with me? Absolute value of a number is always at least, absolute value is never negative, so it's always at least 0, correct? Could be positive, right? So can I do 2 minus a positive number and get negative 5? Yeah. 2 minus what is negative 5?
1. No.
2 minus what is negative 5?
-3. Oh,
If
no.
you have $2, how much money do you have to owe so you're in the hole $5? 7.
No.
7. See, I mean, do you ever have to actually do what I just said? No, you don't have to know ahead of time. You work it out, and there's that number I was just talking about, right? It comes out from what you do. So again, just because you see a negative there, don't assume it's no solution until you get the sucker by itself first. Yeah.
Is that still x plus 3, 7,
So yeah. Now you would just do the two cases, right? Well, it's one case. X plus 3 equals 7 or negative 7. Yeah, and then you solve them both, right? So you get x equals 4 or x equals negative 10. Is that cool? Okay. Yes.
For the problems that are no solutions, is the only way for it to be a no solution is a negative on the far end, or is there something else that?
No, I could do another like 2 absolute value ones that would have no solution. It's just, yeah, it just has to have some more stuff in there, you know what I mean? So yeah, so this is the obvious one, negative number, right? But yeah, that's not the only time. But again, you don't have to know ahead of time. This is one you know ahead of time, so you don't even do any work. But if I had absolute value equals absolute value, you set up the 2 cases, it might lead to 2 contradictions, 2 things like this. And then, oh, there's just no solution at all. Yeah. So you don't know ahead of time. Okay. All right. I think that's enough for today. So we'll pick it up next week. Hope you have a good weekend. Apologize if I'm a little grumpy. I'm a little tired. Yeah. Square root of 9 is 3 because the square root cuts it in half. So 1/3 power would be what kind of root? That square root's 1/2. So you've got some whatever the hell it is. First off, what's a negative power? Yep. Flip it. So I would first flip it, and then what's the root? Good, because the roots are on the bottom of planes. So roots on the bottom, so this will be a cube root of stuff. What's the power? 2. So flip it, put it in, do the cube root, and then the last thing you do is square it. Yep. Anybody not get their test back? Yeah. So this is your test grade? Current, average, and then what if it comes to the mean grade?
Hey, Jeff?
Yeah, it should be F3 minus F1. You have 3 minus 1 on the bottom. Yeah, okay, there you go. That's the main reason I took myself, but I think you're right, you also. Okay. Oh, that's 4. Wait, you have to add 7 first before you make your 2 cases. You have to get the absolute value by itself first, and then you can make your 2 cases. So you made it 4, -4 thing. Okay. But no. The only time, so the absolute value has to equal a number, and then it could be negative or positive that number. So I don't know what the absolute value equals yet, so you gotta add 7 first. Thank you. You're welcome.
Jeff?
Yeah. Oh yeah, thanks, man.
0